Hello everyone. So today we are solving this problem for test Subarray with or at least k. This is second part of this problem. So you are given an array nums of non-negative integers and an integer k. So an array is called spatial if the bitwise or of all of its elements is at least k. Okay. So return the length of shortest spatial non-empty subarray of nums. Or if there is no such combination available, then return minus 1. So what is happening over here is like this. So for example, this is our nums array 1, 2, 3, and this k equal to 2. Then we have to find a smallest sub array in this nums, which has, if we do the OR of all the numbers of that sub array, it should at least give k equal to 2. Okay, so we have to check here. So as we need the smallest one, so if we look at this guy, right, this guy is having value 2. So OR of it would be also 2. So this is length 1, right? We have found one element. So the answer should be 1 here. So this is one favorite example. Okay, let's say we could have some other. Let's say k equal to 25. Okay, so if k equal to 25, then even if we do the OR of all these numbers, still we would not be able to match 25, right? So there would be minus 1. Answer would be minus 1 because there is no possibility. So these are the two favorite cases we have checked, but there could be some other cases. So let's take a better example. So for example, this time I have taken this example 2183. Okay, and our k is equal to, let's say, 10. Okay, then we have to find a subarray. If we do the OR of all of them, it should give me at least k equal to 10 or greater. That is also valid, right? And we have to find the smallest one. So see here, there could be the possibility if we do the OR of 2, 1 and 8, that is also giving us the a greater than value. Okay, so let's say we will do this. Okay, so 0, 1, 0. This is our 2, right? And then we have 1. So this is 0, 0, 0, 1. So what is the answer of OR? It would be giving us 0, 0, 1 and 1. So this is 3 only, which is still not greater than or equal to k. So let's include, we include 2, we include 1, let's include 8 as well. Okay, so this would be like this 1, 0, 0, and we will do OR of them. So what would be the answer? It would be 1 and 1 and 0 and 1, right? So this is now greater than or equal to k. Okay, this is now, so this gives a valid answer for us. So what is the distance here? What is the length of this subarray? Length of subarray is 3, right? But we need to check, there could be further more, right? So what we will do, if we remove this guy, if we remove this guy, then we will have another set here 8 and 3, right? So let's check for 8 and 3 as well. So we will check 1, 0, 0, 0 and 3, right? So it would be 0, 0, 1, 1, right? And then we do the OR of it. So this would be 1, this would be 1, this would be 0 and this would be 1. So this value is also greater than or equal to k 10. But see here, what is the here length of this subarray? Length of subarray is, this case it is 2 only. So if it is 2, that means we got a better answer. So we will not go ahead with 3. So now 2 should be our answer. So basically this is what we have to do, and we are doing this in a sliding window or technique, right? So this is what we have to do. Now we will discuss about how to do that. Okay, so let's take this example itself. This is covering the good cases. Here is like I have created one count integer of size 32. Okay, why this is size 32 is because we know that integers are of 32 bits here. So 0 to 31 we created an array, and what is the purpose of it is, like when we will go through this array, okay, we will count the position of all the numbers whatever is encountering. For example, if we go to 2, right, so 2 would be represented like this 0, 0, 1 and 0, right? See here at the location second location we have 1, right? So we will go to this location, this is 1. So at here, when we will come to here, basically we will increase the count. So this is 0 right now, so we will make it 1, something like that. Okay, so we will go through it. Now we will come to this guy, right? So whenever we are doing this, so see here, After doing this, we will write a method which will convert this entire count array to give the corresponding value. For example, right now this count has only 1. Okay, so if we do the OR of all these numbers, it will give us 1 only, right? It will give us only the value 1. So this 1 is basically right now smaller than k. That means we should not include, means this we haven't got answer right now. Then we will go to the next element. So this is 1. Okay, so for 1, what it would be? For 1, how we write? It is 0, 0, 0 and 1. So means 0th bit is itself is 1. So we will go to 0th bit, will increase by 1. Okay, so right now we have this scenario. So this is also not producing the number that we are looking. So what is that number right now? If we go to the equivalent conversion of this count, so I'll tell you, first let's fill this count array, then we'll check that how to convert it into the equivalent number. Okay, so for now we have filled the 1 and 1 position count here. Now we'll go to 8. Okay, so how do we write 8? 8 looks like this, 1 triple 0, right? So 0 1 2, only third bit is set here, so we'll go to the third location, we'll increase it by 1. Okay, so if we do the XOR of all, if we convert this number which has 1 1 and 1 3 value, we have to convert this to the equivalent number, that what is now it is producing, so that we will check that whether it is going greater than or equal to k or not. Okay, so guys, I'm explaining that whatever count frequency we have got so far, like 2 1 8, right? We have to convert this count, whatever count has, we have to convert it what is the equivalent value. So initially let's say value equal to 0, so I am converting it. So this val equal to val or, and this is one left shift of position time. So for example, it is 0, right? At 0th location it is 1, right? So what we will do is we will do 0. Okay, we will do 0 initial value of 0 and 1 left shift 0 times, right? This is position I equal to 0 here, right? So what we will do, 0 times position, left shift of 0 times of 1 would be that number itself, right? So it would be like 0 0 0 1. So this will be 1 only. So far we got 1. Okay, now we will come to this guy. Okay, so now our value is now 1. So we'll go to next time. This time I equal to becoming 1, right? So val, instead of val I am putting this 1 which we created for the first value. So instead here I have put val and or, and now this 1 is how many times? It is 1 time shift. Okay, so 1 time left shift, what would be the 1 time left shift of 1? So let me tell you. So we can write 1 is looks like 0 0 0 1, right? It would be like that, 0 0 0 1. If we do the left shift 1 time, because I is 1 here, like this, so we will shift everything, it like 0 0 1 and 0. Okay, so this would be our new value. Okay, so we will put instead of this we will write so 1 and or operator with the this value which is 2 basically. So we will write it like this, 0 0 1 and 0, right? This is a sign of the or operator. So what it is giving? It is giving us 0 1 1 0, right? We are doing the or of it. So it would be give us, let me write in a clear way. So see here, our effective or value so far would be 0 0 1 1. Okay, so till here our value was 3, till here we got the 3 value. Now we will keep on going, again we will go, so we will come to here, but this guy is 0, so for 0 we are not interested, right? For 0 it wouldn't make any difference if we do the or. Then we go to the next guy, this is 3, so at 3 we again got 1, so we have to do XOR with this. So what would be the 3 left shift of 1 if we go to this formula? So let's say 0 0 0 1, this is our 1 and we want a 3 position left shift. So what would be the answer? It would be like this. It would be like we will make it this guy 1 time and then 1 more time and then 1 more time, 3 times it has to go into the right direction, correct? So it would be something like this. So in one direction, in one shift it would be 0 0 1 0. Okay, then we have to one more, so in that case it would be 0 1 0 0. Now we have to do one more because we have to do 3 position shift, right? then it would become 1, 0, 0 and 0. So for this guy, we have to do the OR. Okay, so we will write this guy here, this guy here. So 1 triple 0. Okay, 1 triple 0. So what will be the OR of them? So let's write the OR of them. So this is 1 1. So both of them will these guys will come 1, and the next two values are 0, but next two values here 1 0. So it would be 1 0. Okay. Now see here, this 1 0 1 1 is basically greater than or equal to k equal to 10. So we got one matching condition at the position 3, right? So at the position, if we got one matching condition and we started from 2, which was 0, and we found this matching condition at index 2, right? So what is the difference here? 2 minus 0 plus 1. So size is, let's say I am storing the values here in a variable called min. Okay. So min is currently we got one position equal to 3, right? So 2 minus 0 plus 1. So currently we got a condition because at the index 3 we got our favorite value, which is 1 0 1 1, which is greater than or equal to k. But who know, we might have some more values as well, which might give further shorter value, right? So we will go to keep on going right side, we'll check, and just like we do in the windows, so sliding window or technique, right? So what will, if we remove this 2 from our window, then our window go to this way, right? It will go to this way. So if we remove this 2, we have to remove the corresponding bit as well, right? Because we are setting here bit counts. So this 2 would be remove this guy, right? If we remove this 2, this second position bit would be gone, right? So it would be like this. We will keep it 0 here instead of it. Now we have this array, right? We will check whether, hey, with this technique, what would be the value here. So if we go in this way, if we keep on checking that, so we have only two things. So first of all, what we will do, initially value would be 0. So if we do the OR here, it would produce only one value. Okay. Then we will come to this guy 3. So we have to do this thing, same thing, the one which we got here. So we have to OR with this guy. So it would be 0 0 0 1 and OR with this guy 3. So at 3 position shift, and at 3 position shift what we found, at 3 position shift we found this guy 1 triple 0, right? You remember, but what is the, what it is producing, it is producing us 1 0 0 1, which is 9, right? So 9 is still smaller than k, so our condition is still not matched. So as you guys can observe here, this value is basically 9, right? So that means that this is smaller than k. That means we removed 2, but now as we got a smaller value, that means we have to go to the right side. So our end should be increased, right? So far our start is right now at here, and our end would be increased now because we got a smaller value. So we need a greater value. So our end would be this is 0, 1, 2, and 3, right? So our end was here. So our end would now come to here. So end would become 3. Okay. So at 3, what it is? It is 3 basically. Okay. So how do we write 3? So 3 we write this way, 0 0 1 1, right? This is the way of writing a 3. Now we have to update this guy. So see here, on 0th location it is 1 bit, on second location also it is 1 bit. So we will go to this guy. So 0th location it is 1, right? So we have to increase it by 1. So at 0th location it is 1, so I am increasing it by 1. So 0th location now it would become 2 because total 2 bits are there. We increase it by 1. Now come to this guy. This is also 1. So this guy 0 plus 1. We increase it by 1. This as well. Others are 0. Now we'll evaluate what is the final value coming here. Okay. So let's I'm removing these values. We have to again calculate everything from the start. So val is again now 0, right? We have to find this value. So in val we will put 0, and yeah, so let me write here it is 0. So all of them are 0, and what is the value? So first of all it is 0 time 0 left shift for this bit. Okay. So 0 or with 1 left shift 0 times. So this is 1 only, right? Would be 0 0 0 1. So what is the answer? Its answer would be 0 0 1 only. 0 0 0 1. Now we'll go to the next one. What is the next? Next is again we are finding another greater than 0. So what we'll do, we will do the OR with this. So 0 0 0 1 is our val now, and we will do OR with this 1. Okay, so 1, so this is the position of one time. So we are doing the one time left shift. So what would we to produce one time left shift? One time left shift produced will be this 0 0 1 0. So 1 will be left shifted by one time here. So what will be the OR here? So OR would be second and first. So it would be 0 0 and 1 1. So far we got this value. Now we'll go here. This is 0, so we don't have to worry about it. Now we'll come to here. So 3. Okay, so one position 3 times shift. So let's put this value. We will put it here like this 0 0 1 1. And what would be the 3 times shift of 1? Left shift of 1? It would be 1 triple 0, right? We did already 1 triple 0. So what would be the OR of it? OR of it would be 1 0 1 1. Okay, so what is this value? This value is greater than or equal to 10, correct? So condition is satisfying. So condition is satisfying. That means, so what is the difference? So start is our at 1 and end is our 3. So 3 minus 1 plus 2, 3 minus 1 plus 1, right? So what it is making? It is making 3. But we already found 3, right? So it is still kind of same thing. So we don't have to update it. Now what we will do is, by the time it is greater than or equal to k, we have to increase our start this time. So we will, our start would come to here. So we will remove this guy 1. So 1 is condition, 1 is producing to 0th location, right? Just like 0 0 0 1. So it is the 0th set. So we will decrease this guy by 1. So if I decrease this guy 1, it would become what? It would become 1, right? So this will become 1. Now we will again do the evaluation of this. So this evaluation would come same. This would again come this value, the same which we just got it, this one. Okay, so what it is value? This is greater than or equal to k. But what is the difference now? The difference would be, our start would be here, which is 2. So end minus start plus 1. So 3 minus 2 plus 1. What is the difference? So this would be 2. So what is the value now? Value is 2 here. And what we already recorded, this is 3. So we will remove this 3. We have found another smaller value. So now it is 2. Now by that time our things are done, right? So our final value is 2. So this is how we have to proceed it. So you guys can check here. Initially I just created an count array of 32 size, because we have the 32 bits integer size, and these are my start end. And see here, I am initializing my min value with the integer dot max value, right? Because we are finding the minimum value. So see here what I am doing, while end is less than nums dot length. So this is my update bits method, where we were making these count, right? We are putting these count values into this array. That portion I am doing here. So see here, this is my update bit method. So what I am doing is just using one for loop and looking for the right shift of whatever position we have, right? So see here, we are passing three variables, count array and the variable number, whatever number we are calling it, and this is value. So this value could be 1 or minus 1. So in case of we are decreasing, then we pass minus 1. In case it is we gonna increase the position values, then we gonna pass 1. So see here, we are traversing through 32 bits, and see here what we are doing, whatever number we are passing here, we are making the right shift of this I times. Why I am doing this? Because we want to check the ith bit, whether it is 1 or 0. So how will we come to know? So if we, for example, let's say, let me explain it. Let's say we have a value, suppose we have a number equal to 1011, suppose. Okay, so let's say I have 1011. Okay, and I want to check the this bit, that what this bit is. Okay, so what I will do, I will do the right shift of this bit. So this position is 1, right? So I will do right shift 1 time. So what will happen if I do the right shift 1 time? Okay, so if I do the right shift 1 times, it will look like this. So it would be 0 1 0 and 1, right? And now if I do the ampersand with 1, so 0 0 0 1, if I am doing the ampersand here, what it will be produced? it will produce here only this is the place where both of them are 1. So it will be produced 0 0 0 0 0 1, right? So now I can say that this is the 1. So if it is producing 1, so if we do the right shift I times, if we are finding the ith position whether it is this bit is set or not, we do the right shift I times and we do the ampersand with 1. So if it is producing 1, that means it is a set bit, otherwise it's not. So this is what I am doing here. So I am doing nums, I am checking the ith bit. Okay. So nums right shift I times and do the ampersand with 1. If it is producing 1, that means that ith bit is set. That is why at ith location I am increasing the count by val. So val in the sense I am passing 1 if we are increasing. If we are removing, like in sliding window we were removing here, right? We started removing here, removing here. At that time we have to pass here -1. Okay. So that is why I am taking this general sentence plus val. Okay. So this is my update bit and this is the method where we convert this whatever count has. This is the method when we were converting it into the equivalent number, right? See here, we are passing this count, we want to what is the equivalent number. So see here, we are using this for loop, and if count I is greater than 0, just we were doing here, right? That whenever we were founding a value which is greater than 1, greater than 0, then only we will doing all this operation. So for same reason I'm writing this piece of code, that if it is greater than 0, then we are doing answer equal to answer or with 1 and the left shift I times, as we explained in many examples. Okay. So this is the way when we will finally return the answer. So this method, what it is doing, it is doing what is the current count array, what value it is producing. Okay. And this method is basically to update the count bits, set bits, right? So these are two utility methods. Now I will come to here. So here we are going to sliding window technique. We have a start and end like we have every time for the sliding window technique. So see here, I am calling this update bits function, so that at the okay, nums end, whoever is sitting at nums end, we will have the count array updated with the set bits. Now we are checking, right after doing this, we are checking that, hey buddy, for start less than, while start is less than or equal to end and the value of count is greater than or equal to k. That means we found one solution. In that case, what I am doing, I am updating my min. So min equal to min and end minus start plus 1 whenever this condition is matching. Okay. And after doing this, what I am doing is, I am again calling this update bits. So see here what we are doing is, when we matched our condition, you can see here, when we matched our condition for this sub array, we started removing the start one, right? Keep on start one removing. So for same thing, what I'm doing here is, I'm starting this start plus plus, right? So I just updated it with the -1. Okay, so that it will be decreased like the way which we decreased this guy when we were removing 1, when we remove 2, then we remove 1. So that is why we are passing here with the -1, because we have to decrease the counts whoever is getting removed. So see here, I am making start plus plus, that means start 1 we already removed, then we are going to the next value. Okay, so we are doing this till the time we are getting the greater than or equal to value, because we are looking for the smaller value. So after we will come out of it, we would have the minimum value, right? So we will check here. Let's put one more check here, that if min equal to integer dot max value, means the same value which will be initialized initially. So if it is still same, that means we didn't find any matching condition inside these loops. So if that is the case, we are returning -1. Otherwise, we are returning whatever the min value has. Okay. So this is what we are doing. It is happening in O of n. Okay. So we are not taking, we are taking the constant space. So we can still say that the space is also constant. So O of n time complexity and space complexity is constant. This is what we are doing. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.